In this video, we're going to talk about graphing quadratic functions that are in standard form. So remember, standard form is when it's in the form f of x equals ax squared plus bx plus c. But it's difficult to graph in that form because it's not easy to pull out the information just by looking at it. So what we can do is we can complete the square and get it into vertex form, which we did previously, where a times x minus h squared plus k, and then we can pull out the vertex and other information about the function just by looking at the vertex form. So, completing the square, if we recall, when we complete the square, we want to get it to factor into a squared binomial, and we need to find that perfect number that's going to make it factor into that. So when we look at this, it's not that -5 is not really the number we need to get it to factor into a squared binomial. So we have to find that number using b over 2 squared, just like we did back when we did the completing the square section. Now this is going to be a little bit different in the sense of before, when we did completing the square, we would just add the same amount to both sides. But now we don't want to do that because we want to leave this f of x alone, right? Because this is f of x equals da 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 da. So we don't want to change this. So we don't want to add things to both sides of the equation. So how do we alleviate that? Well, whatever we add to the right-hand side, we also subtract. So if I added 2 and subtracted 2, I've added 0. So I haven't changed it, okay? So that's the goal. So, using b over 2, we identify b is -4. So -4 over 2. -4 divided by 2 is -2. And -2 squared is +4. Alright, so here I go. I'm going to leave x squared and -4x alone. And then I'm going to add 4. But also subtract 4. So this is what we've added and subtracted, and we still have that -5. Don't lose that. So the x squared, the -4x, and the -5 all stayed the same. I used my b over 2 and squared it, and I added 4 and subtracted 4. So this adds up to 0, and I've added nothing. And now I'm going to factor just these 3 terms, right? Because those are supposed to be the perfect squared binomial terms. If I factor that, I'm asking what would multiply to 4 and add to -4, and I get -2 times -2 would give me +4. -2 plus -2 would give me -4, and so that's going to be, they're the exact same terms, right? It'll be x minus 2, x minus 2, which will leave me with x minus 2 squared. And then I add up my like terms. -4 minus 5 is -9. And now that's in my vertex form. Okay, so I can pull out my vertex. It's going to be the opposite sign in with the x, so +2, and k is -9. And then we're also asked to find the vertex and any intercepts. So remember, intercepts are where it crosses the y-axis and the x-axis. And the way we find those intercepts is by letting x equal 0 or y equal 0. So if I let x equal 0, that means I'm plugging in 0 for x. And I'd get 0 squared minus 4 times 0 minus 5. 0 squared is 0. 4 times 0 is 0. So f of 0 is -5. And that gives me the ordered pair 0, -5. So there's another point on my graph. That is the y-intercept, right? We let x equal 0. This is the y-intercept. If I let y equal 0, well, y is the same thing as f of x. So that means I'm letting all of f of x be 0. So I'm replacing the left-hand side with 0. And I'm going to solve for x now to find the x-intercepts. First attempt should be to factor. So if it is factorable, we're going to try to factor. If it's not factorable, then we use the quadratic formula. So what would multiply to negative 5 and add to negative 4? I'm thinking negative 5 and a positive 1. So negative times a positive would give me negative 5. Negative 5 plus 1 would give me negative 4. So those are my two factors. My leading coefficient is 1, so I can go right into my factors of x minus 5, x plus 1. That means that x equals 5 or negative 1. And remember, these are x-intercepts, so those are ordered pairs of 5, 0, and negative 1, 0. So now I've got 4 points that I could plot on my graph. I've got the vertex at 2, negative 9. So I think it's going to go off my graph here. So 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I need to go down off my graph here a little bit. Apologize for that. Let's count it again. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so there's my vertex. It's off my graph a little bit. And then we have the y-intercept at negative 5. So 1, 2, 3, 4, 5. And we have the x-intercepts at positive 5 and negative 1. So negative 1, positive 1, 2, 3, 4, 5. Remember, x and y intercepts need to be touching the x and y axis. And there you go. And then I also know that my graph is going to be symmetrical. So I can also, since I have this point here, I know it's going to be symmetrical over here on the same line over 2 from the vertex, over 2 from the vertex, just to even it out a little bit. Alright, so there's my graph. Connect the dots, making a U shape, not a V shape, and filling my graph. And there you go. And then the last thing it asks is for the line of symmetry. So the line of symmetry always goes through the vertex, and it's that line that gives the mirror image. If I were to fold this in half, they would be identical on either side. So that line is cutting through the x-axis. It's a vertical line at x equals 2. So the axis of symmetry is a line, so it needs to be an equation, x equals 2. So we've got all this information here. The vertex, the y-intercept, and the x-intercepts. And there you go. Why don't you try the next example? Alright, let's see how you did. So again, we are starting with the function x squared minus 4x plus 3. And we want to get this into vertex form so we can graph it. We use b over 2 squared. b is negative 4. It's always with the x term. Negative 4 divided by 2 is negative 2. And negative 2 squared is positive 4. So when we add it to our equation, we have to also subtract it. So we add 4 and subtract 4 at the same time. And we still have that plus 3 there. Now we we factor just these first 3 terms. And we want something that will multiply to positive 4 and add to negative 4. That would be negative 2 and negative 2 again. So it's going to factor into x minus 2 times x minus 2, or x minus 2 squared. We don't forget to add. Negative 4 plus 3 is negative 1. And now we can pull out our vertex. Our vertex will be at positive 2, negative 1, right? So we take the opposite of what's inside with the x. What would make this 0? That'd be positive 2, and the k stays the same as negative 1. Alright, so there's part of our answer. We have a vertex. Now we also need any intercepts and the line of symmetry. So intercepts fall on the x and y axis, so we can let x equal 0 to find the y-intercepts, and let y equal 0 to find the x-intercepts. When we plug in 0 for x, we get f of 0 equals 0 squared minus 4 times 0 plus 3. Those are 0. 0 squared, 0 times 4. And that leaves us with f of 0 equals positive 3. So that is the 0.03. So that is our y-intercept. Now we can go over here and find our x-intercept by plugging in 0 for y, and y is the same thing as f of x. So 0 equals x squared minus 4x plus 3. We want to try to factor first. If it's not factorable, then we use the quadratic formula. But we check to see if anything will multiply to 3 and add to negative 4. So I'm thinking negative 3 and a negative 1. Because a negative times a negative will give us positive 3. Negative 3 plus negative 1 is negative 4. Our leading coefficient is 1, so we can go right into our factors of x minus 3 and x minus 1. That means that x could equal positive 3 or positive 1. And those are two separate x-intercepts at 3, 0, and 1, 0, right? Because we plugged in 0 for y. So those are two separate points on our graph. Alright, so now I've got some points. I can plot them. I go over 2, down 1 on my axis. Over 2 on the x, down 1 on the y. And that's my vertex. The y-intercepts are going to be, or y-intercept is at 0, 3. So up 1, 2, 3 on the y-axis. And then my x-intercepts, I go over 1 on the x-axis and over 3 on the x-axis. And again, my graph will be symmetrical, so I can also fill in this point here to give that mirror image. The mirror image will happen across the axis of symmetry, which goes through the middle. And so that is cutting through the x-axis. It's a vertical line. The equation is x equals 2. These two examples happen to both go through x equals 2, but there are other axes of symmetry. I connect the dots, and there's my parabola. And there you have it. So that's the way you do it. So complete the square to get it in the vertex form. Pull out the vertex. Let x equal 0, find y. Let y equal 0, find x. If there are, sometimes there's not x-intercepts. And then factor it. If it's not factorable, use a quadratic formula. You could end up with some irrational numbers, right? So if you have to use the quadratic formula, it's going to end up irrational. There you go.